Okay, this is the last factoring that we're going to look at is the perfect square trinomial. All right. For a trinomial to be a perfect square, it's got to meet some conditions. Okay. First of all, a trinomial has how many terms in it? 3. Okay. So it's got 3 terms. Your first term and your last term must be perfect squares. So you've already gotten a little bit of practice on this. Your middle term, and I'm going to rewrite this. Your middle term is going to be 2 times the square root from the first term and the square root from the last term. So this is kind of like your difference of 2 squares. There's a pattern that it follows. That one follows. This one also follows a specific pattern. Okay, so here is an example of a perfect trinomial square. I'm going to show you how the pattern works. So we're going to establish, would you agree with me that both of these are perfect squares? Okay, so the square root of 9x squared would be 3x, and the square root of 4 would be 2. All right, let's multiply those together. If we multiply 3x times 2, we get a what? 3x times 2, yes, we get a 6x. And now we're going to double it. So I'm going to double it, and I'm multiplying by 2. And what does that give me? 12x. Look at your middle term. Look at your middle term. Okay? So that's the pattern. So if you have a trinomial that happens to fit, all these pieces fit, then you have that perfect trinomial square. Questions? So I'm going to come over here. I know that's my A and I know that's my B. So I'm going to factor that into 3x. My middle term is plus. My B is 2, and I square it. And that's my factored form. Okay? So that is right here. If you look up here, that's how we get it back. That's the connection. Okay, so what we're going to do is we're going to practice and see if we see the pattern working. Okay? If our pattern holds, then we will factor it into our binomial. Okay? So let's take a look at our first one here. 9x squared minus a 15x plus a 64. Okay, looking at that, can you establish that the first term and last term are squares, perfect squares? Yes?
I have a question. Is there any way that it could be, because it's negative 15, but those are both positives?
Yes, it'll work.
Oh, okay.
Yeah, you'll have some with the negative. That's one of them. Yeah. So let's try it. So what's the square root of 9x squared?
3x.
What's the square root of 64?
8.
Okay, now let's see if our pattern works. So if we multiply those together, we would get a what? 24x, and then if we doubled it, we would get a 48x. Is that our middle term?
No.
So would this be considered a perfect trinomial square? No. So what would you have to do to factor that then? You'd have to go back to what method? You'd have to go back to your big ol' X, right? And you'd have to do that. Okay? It's nice to have these because then you don't have to go through all that, but it won't work every time. It'll just be cases. Okay, let's try another one. Okay, let's try this one. This is an 81x squared plus a 90x plus a 25. Okay, so we're gonna see if our pattern holds. If the pattern works, we're gonna factor it, and then if not, we're gonna look at it and see why it doesn't work. So first and last terms, are they perfect squares?
Yes.
Yes. 81x squared would give you a 9x, and a 25 would give you a 5. Okay, let's go through our pattern. If we multiply those two together, we get 45x, and then if we double it, that would give us a 90x. Is that your middle term?
Yes.
Yeah, it is. Okay, so we're going to be able to factor this. So we know the 9x is the A, we know that the 5 is the B. So that's going to be put into our A plus B squared. And why did I choose plus? The B. Yes, very good. Thank you, girls. Because the B is positive. So that's going to look like what? So that's going to be, what's our A? 9x plus 5 squared. And that's it. Yep,
So
that's
that's
it.
all you have to do.
So now then, if you wanted to find the 0, you're just going to have to do it once, right? You're just going to have to do 9x minus 5 equals 0. This is the case where you only have, and that would be what? If we move the 5, yeah, that would be a positive 5/9. This is the case where your parabola only has one 0, so that means the vertex is sitting on the y-axis. In this case, is this one opening up or down? Up. So what's happening is it's coming down, it's hitting the x-axis, and then it's popping back up. So this is a case where you have 1. Yeah, okay, so go, yes, I wrote that down. So it's 9x plus 5, and so therefore ours would be negative. Yes, thank you, Emily.
Oh, okay. Yeah.
Why did I do that? How about this one? How about this one? 36x squared minus a 10x plus a 14. Let's determine whether this one is a trinomial square. Okay. Yeah. This kills it, right? 14 is not a yeah. Oh, we're going to get a huge number. We can try it. Well, we can try it. Okay, so this one doesn't work because that 14 is not squared. Okay, we have a function here. G of x equals 3x squared plus 18x. And we are going to find our zeros. I'm going to find our zeros. How are we going to do it? So we're going to look at our factoring organizer, first of all, to help us start this. What should we do? We need to check for our greatest common factor.
Is this a new section?
Do we have? No. Well, yeah, you could just say in general. Just not, yeah.
What should I call it?
Factoring. Equations. Do we have a greatest common factor? Yes, we do. What is it? 3x. All right, so let's factor that 3x out of there.
Peters.
What are we going to have left inside?
Irvs, Jerry Terry,
X.
Waldron, Bryant,
X plus
Friedman,
6.
Clout, and Glover. Glover, Jolivet, and Clout.
Okay, remember we're wanting the zeros, right? Remember we're wanting the zeros. Okay, this looks a little different from our other ones, right? Okay, this is different because, and this is also a pattern that you can always count on. When we did our greatest common factor, we actually factored an x out, okay? This is being multiplied by the binomial, okay? So we're still going to make use of that zero product property. Either this is going to equal 0 or this is going to equal 0, okay? Just like we did with the two binomials. So we're going to do this. We're going to say, okay, 3x equals 0 or the x plus 6 equals 0. So if I'm looking at the 3x equals 0, what does my x have to be in order for this to be 0? 0. So if you have a greatest common factor and you factor an x out, one of your zeros will be 0. So where is that hitting? It's hitting at the origin. Yeah. Right? It's going to be at 0, 0, which is the origin. What's your other 0 here? Negative 6. Negative 6. Okay?
So that one would hit at negative 6.
Let's do this one. We have an x squared minus an 8x. What can we do here? What? Zoe, Zoe. What is the greatest common factor?
1x.
X. Okay, so take him out. We're going to take out the x. What's that leave you with?
X minus 8. Oh.
Ooh. 4. About 8.
Okay.
Yeah. Now you're doing what I'm doing. I'm like, okay, so again, we factored an x out as the greatest common factor. So you're going to see that pattern hold. So either the x equals 0 or the x minus the 8 equals 0. So again, you got one of your roots to be a 0, right? What's it going to be over here?
Teachers,
X
you can
equals
escort your students down for sea lunch.
8. X equals 8. No, we're the last ones.
30 minutes.
You got way too excited.